So we have so far discussed 5 lectures. All these 5 lectures are introductory lectures only. Our course starts only from this lecture 6 onwards, but we have given elaborate introduction because when you want to learn a subject, not for getting grades or marks, you should know what is the background. The background I have given. In the background I have given 5 lectures, all the important points that are to be considered for port and harbor structures. So from now onwards we will be giving in detail about various components. This figure shows the layout of Chennai port. Here the construction is going on, as you see here from the satellite imagery. This is a second container terminal, and this is the entrance to your Jawahar dock, it is shown here, and this is the breakwater which was extended here like this. Original breakwater alignment you can see here like this, it goes here and goes here like this. This area is being filled up here, that work is on progress. So we are going to discuss about the design of this breakwater, how to design this. So as you see here the waves are coming, it can come in this direction, can come in any other direction also. So this breakwater should not get disturbed because of these waves, should not get damaged also. First definition, breakwater is a structure protecting a shore area, harbor, anchorage or basin from wave disturbance. The general definition, but main purpose is this is a structure to protect the basin from wave disturbance. It can be two types, one is rubble mound, another is concrete caisson. I will show the figures, or a combination of these two, that is called as a composite type. This breakwater can be connected to the shoreline and extending out into the water, but sometimes the construction is the breakwater construction is mostly parallel or perpendicular to the coast. So it is not that it is always parallel to the coast or always perpendicular to the coast. As you see in the previous slide, it can be either parallel or perpendicular. To maintain tranquility, you know what is meant by tranquility? What is tranquility? Tranquility is calm. See, tranquility is a word, the physical meaning is calm, calm condition in the port. Tranquility means the wave disturbance, you said wave disturbance should be reduced, that is the purpose of the breakwater. There are 3 major categories according to the functional requirements. One is called as rubble mound breakwaters, or simply called as mound type. The next one is vertical breakwaters, this is called as wall type. Then we have vertical wall on rubble base, it is called as composite type. See, whenever you study any subject, when they are giving 3 different types, you should find out when each type is used. There is a reason for that. If you are using a vertical wall on rubble base, a composite type, there must be a reason where we have to use that. If you are using a rubble mound, you should know where they are using it. You will get to know more about at the end of the lecture, but in this continuation of this, we will see which type of breakwater is to be selected. These are controlled by some factors. One is availability of rock. The rubble mound breakwater, mostly we will be using rock. The rock is available nearby. Nearby means how near is near, it is about 30 kilometers, sometimes even 60 kilometers, but if it is more than 100 kilometers it is not near. Another thing is there should be there are certain conditions for this rock, it is not all the rocks can be used for breakwater construction. So the rock that can be used for construction, if it is available, let us say within 30 kilometers, then we can go in for rubble mound type. 60 kilometers also is possible, At more than 100 kilometers we should think of some alternatives. Depth of water. So this depth of water is another important parameter. Suppose the depth of water is less than 15 meters, 15, then we can go for either rubble mound or vertical breakwater. But if the water depth is more than 15 meters, then we have to go for composite type. Greater the water depth, you have to go for composite water type. Geotechnical nature of seabed. So what are the type of soil I said? What are the different types of soil that can be encountered?
Sandy and clay.
Sand and clay. There is one more in between, that is silt. Then another soil, that is rock. So you can have either clay, silt, sand or rock. So out of all these things, if rock is available, that is this availability of rock is for getting the stones for the breakwater, whereas this rock what I am telling is the seabed rock. If seabed rock is available, then we can go in for vertical breakwater. Vertical breakwater is a concrete CAISSON type, so the load intensity is very high. So if you have a good foundation, we can go for vertical breakwater. In sand, if it is a very dense sand, then we can go for vertical breakwater. But if you have a very soft soil, clay or loose sand, then we have to go for rubble mound. But it is not only the soil which is governing, you have the other two parameters also, you have to see it in combination. Even if the soil is rocky, still we may go for rubble mound breakwater because rock is available, depth is less than 15 meters. The function of breakwater. The function of breakwater is generally to protect the harbor against the waves. But sometimes what they do is on the lee side means back side, the back side of the breakwater, if you want berthing to be carried out, then we go for wall type. Is it clear? Rubble mound breakwater means it has slope on both the sides, sea side and the harbor side. Vertical wall type breakwater means it has vertical face. So one side of the breakwater we can go in for berthing of vessel, that is on the harbor side, then we go in for vertical breakwaters. So this is the way in which you have to understand the subject. You should know what are all the three different types, then you should know where this will be used, what condition you have to choose. But in India we normally use rubble mound breakwater only, most of the places. There is one reason for that, that is the technology, availability of construction equipments. The vertical breakwater means you have to build the caisson elsewhere, either you have to lift it or you have to float it and sink it, that is more expensive. In Indian condition, transporting the rock from the quarry to the site and placing it will be cheaper because lot of man hours are required for that, whereas vertical breakwater man hours are less but equipment cost is more. In Japan and all they go for vertical breakwater, whereas in India mostly we go for rubble mound breakwater. So if you want to design any structure, either you can use a numerical method or use a experimental method. Experimental means physical model studies are to be carried out to see whether the structure what you have designed is appropriate. Mainly in ocean engineering and port and harbour engineering we use physical model studies, but for breakwater it is mandatory. You know what is meant by mandatory? What is the meaning? Compulsory. You have to do a physical model test when you do a rubble mound breakwater. Mainly this is because the formula which is used is semi empirical. Semi empirical means it is not having 100% analytical or numerical basis. There are certain formulas which are derived based on experiments and based on certain concepts. So when you are designing that, then there is likelihood of certain inconsistency or certain deficiencies in the design. So take care of that, you have to do a physical model studies. Another thing at this level of higher semesters of BTech and post graduation, you should know that whatever structure you are designing, sometimes it becomes impossible to make it 100% foolproof. So you would have seen the recent cyclone that is called as Thane cyclone. What happened? Most of the electrical distribution systems have failed, that is the towers have fallen down. You may wonder whether we can design it to resist this wind force. Wind is very high, we have not designed for that wind force. Why we are not designing for that wind force? What is the reason? Is it that we do not know that this much wind will occur? Then why we are not designing? Or we do not know how to design? Why this failure has taken place? It will take 1 month to restore the power. Why are we not designing for the wind force?
Probability is less.
What is it?
Occurrence is less probable.
Occurrence is less, but still occurred.
Design for the probability, right? 100-year probability.
No, 100-year probability this may come, but we might not have used it. Yours is a very good answer, but still if it is coming in 100-year probability, we may not design. Why? See, 100 year is a return period. Once in 100 year, whatever is the wind that is coming, we will use it for the design purpose. See, it is only the cost factor. If you are designing for the wind, your structure becomes very heavy. Sometimes you may not have the cost, you may not have the finance to build for that. So these are the two reasons. One is what is the return period which you are considering. Mostly what they do is there is certain structures we have seen which are designed for 1 in 100-year return period, they fail, then we go for 1 in 1000-year return period. The Gulf of Mexico, where we have mostly offshore platforms, certain conditions we will be designing it for 1 in 1000 year. Certain condition means not the design of the structure, we know what is the air gap that is required. Air gap means water level plus of the wave height, then 1 meter air gap. For that case wave height we take 1 in 1000 year, only for the air gap, because if the wave is hitting the bottom of the deck, the wave force will be enormous, we want to avoid that. You understood now? The return period that is used for design condition is not the same for all. One is to find out the forces in the members, another is to design the foundation, the third one is to fix the top level of the structure. For all these things we can use different design wave conditions. Similarly design wind also you can consider, one is for operation, another is for extreme condition which will be used, for which this will not be falling down. I do not know what they have done, whether they have used 1 in 100-year wind or otherwise. Even if you use 1 in 100-year wind, there is what is known as gust. Anybody know what is gust? Wind speed. So for example, you are measuring the wind over a period of let us say 12 hours and take an average, that is one wind speed. If you measure over a period of 1 minute, over a 12-hour record, you select 1 minute where the wind is very high, that will be another wind speed. Average is not the same. I think today because of Sarang the class is very less. You take the average of this class, you take the height and take the average, you will get one height, one average wave height. Suppose all the students are here, then take an average, another average will come. Like that, depending on which duration you are taking the average, it will be different. Gust is over a smaller period when you take the average. We may not design it for that, even if you take 1 in 100 year, we may not take the average of a shorter wind period. So normally in design purpose wind we do it for gust also. So in this case when you do a rubble mount breakwater, what they assume is they assume about 5% damage. 5% damage criteria means whenever the wind for wave for which it is designed it occurs, certain components of the breakwater may get damaged, but the damage should be limited to 5%. After the damage is over, after the cyclonic storm has receded, 5% damage has occurred, you have to go and repair the structure. It should not be complete collapse, but we permit 5% damage. That is how the formulas are developed. So now we will see rubble mount breakwater is constructed by a heterogeneous assemblage of natural rubble or undressed stone. Rubble means stone only, undressed stone. Undressed means you do not make it perfect. If you go to temples and all, they make the size perfect, but perfect size is not good for rubble mount breakwater. You should not dress the stone, it should be random in shape. What is heterogeneous? What is the literal meaning of heterogeneous?
Different kind. Mixture of different kind.
Yeah, it is here, it is mixture of different size. So we have different types of rubble mount breakwater. We have beam breakwater armored with natural rock, then we have conventional multi-layer breakwater with armor over crust, no crown wall, conventional multi-layer breakwater with the crown wall, then we have a composite structure incorporating CAISSON with armor protection. These are the various types. We will be discussing these two types, conventional multi-layer breakwater with crown and without crown. This shows the rubble mount breakwater. I will be asking you to draw this figure, so you please try to draw it to the scale in which it is drawn, do not draw to some other scale. And I also would like you to have the proportion of the thickness what is shown here and the various layers. The previous slide we have shown it is a heterogeneous mixture of stones, size of stones. So we have, starting from the bottom, we have what is known as a bedding layer. You remember that we are working in the sea and we are dumping the stones from the barge or by end-on method from the already constructed breakwater. The control is difficult to achieve, but still we are able to achieve certain controls. So initially we have what is known as a bedding layer. The bedding layer thickness is uniform for below the core, whereas we need this toe. The toe, the bedding layer is slightly higher thickness, then this we provide, I am sorry, over the bedding layer we provide the toe, and I should not have shown the same color, the toe is slightly different color. Then we have a under layer, the under layer also goes like this. Sometimes we may use the bedding layer itself as a up to this portion, then use this under layer as a toe layer, otherwise we will do it separately also, either way it is possible. So one thing is to have the same bedding layer continued for increased thickness, then have the under layer, or have the bedding layer like this itself, then provide a uniform toe layer which will be different from the under layer. Then we have the core layer. More than 50% of the stones used here for a rubble mount will be in the core layer. Then we have a armor layer, then we have the crust. On top of the crust we can have a wall that is called as a crown wall. So we will have the waves coming from one side, this side if it is wave is coming, this is the sea side, this side is the harbor side. Typically the top weight is about 8 meters, but if it is for fishing harbor it can be about 4 meters. We cannot have anything less than 4 meters because we need certain vehicle to pass through this. So when a vehicle has to go, there should be minimum width available. So this is like this, and there is a slope here. This slope is typically 1 vertical to 2 horizontal, 1:2 slope. Similarly here it can be steeper, 1 vertical to 1.5 horizontal. So we have the road which is formed separately by a crust, then we have the armor layer, under layer, core layer, bedding layer, and these toe layers are important, because whenever you see any failure of any type of structure, 90% of the failure can be associated to one component. Any type of structures, any failure, the reason can be, mostly it will be the same for 90% of failure. This toe failure is one of the main reason for most of the failures of rubble mount breakwater. So the toe has to be done properly. It is a complete collapse may take place if there is a toe failure. Any structure, there are certain components which fail, which triggers the collapse, you should know that. This also shows the typical cross section. In this cross section we have the, sorry there is a mistake here, this side is the harbor side, this side is the sea side, then we have this artificial armor units, it is called as armor layer with armor stones, and we have the stone which is called core layer which is quarry run, there is a concrete cap, there is a slope 1 vertical to 1.5 horizontal. Here the toe is not shown here, sometimes toe is not required if the water depth is less, and we have the armor layer, under layer 1, under layer 2, then we have the core layer. This is the shape of the armor layer. I have this, this is another type of armor layer, this is called as core lock, this is a patented technology. This core lock has certain advantages because interlocking is better. When you dump the stone, no, the interlocking is not good, whereas here the interlocking is good. And another thing is this can be with single layers. So if you see this figure, what is written in the figure is 2 layers of armor blocks. We have to put 2 layers. Suppose you use this type of tetrapod, we should put only 2 layers. If it is stone also you have to put 2 layers, but with this core lock we can put single layer alone. But this is a patented technology, you have to pay some royalty for this. In Ennur port they have used this armor layers. The other type of breakwater is called as vertical wall CAISSON breakwater. So as you see here there is a vertical face, this can be made of concrete or steel, here they use a steel sheet pile wall on either side, then in between they are filled with sand, and then they have put a cap on top of it. They have provided some riprap on either side as a toe protection for this steel sheet pile wall, and since it has a vertical face, suppose this is the sea side, the harbor side you can bring in smaller vessel and berth, that is the what is called as function of the breakwater. Is it only for breaking the waves or for using the lee side as a berthing. This is offshore breakwater. Offshore breakwater means the top level is very close to the design water level. These are the various armor units, is called as tetrapod, the plain cube, this natural rock, this is called as acropod. Acropod is same as this only, but slightly different in shape. So these are the different examples. Now we will see what is vertical breakwater. Vertical breakwater is formed by construction in a regular and systematic manner of a vertical wall of masonry, concrete blocks or mass concrete with vertical and seaward face. See, when we discuss about the breakwater, whenever there is a energy from the wave is formed by the wind. See, whenever there is a wind which is blowing in the sea over a area which is called as fetch and for a considerable duration, then the wind is transforming the energy into the sea, which creates the waves, and the waves are created when the water surface goes up. Due to gravity, waves come down, that is why this is called as gravity waves. So these waves, when they are formed, the energy has to be either absorbed or reflected when it comes to the breakwater. When you see the rubble mount breakwater, the waves will come and hit the rubble mount slope, and there is a voids in that. So through the voids the energy will get dissipated, and the waves also will run up means it will climb over the top. So that is called as energy dissipation. That is the concept of rubble mount breakwater. Whereas in a vertical phase breakwater, the incident waves are reflected without dissipating much wave energy. There will be some dissipation devices in a vertical phase, but that will be very less, maybe 70 to 80% will be reflected. We are not absorbing the energy. So normally we construct this vertical breakwater where the depth of the sea is greater than twice the design wave height. So this is another consideration which I have not told earlier. So whenever the design wave height is when the water depth is twice the design wave height, then we go in for rubble mount breakwater. If the depth is less than twice the design wave height, let us say the design wave height is 5 meter, twice the design wave height is 10 meter, the depth of water is 15 meter, then we go for this. The depth of water is 10 meter, we go for rubble mount breakwater. This shows the vertical phase breakwater where we have a rubble mount foundation. Composite breakwater is also like this, but normally even when you use a vertical phase we provide some base foundation. So this is the water depth in front of the caisson, this is the water depth with respect to the seabed, this side is sea side, this side is harbor side. We have shown the waves here, we have not shown the waves here, it means the waves get dissipated here. There is a crest elevation, the top level. So whenever the waves come here, it not only gets reflected, the wave also runs up on top of this. So there should not normally this is non overtopping, that means the waves will not be allowed to go on top and go to the other side. It is called as CAISSON. The width B is the main parameter that you have to design in this case. Due to the weight of the caisson, there is a weight here, due to wave there is a horizontal force. So the base friction into the weight mu into V should be greater than the horizontal force due to the waves, that is the concept for the design. The B is important because whenever there is a horizontal force coming, it creates a overturning moment, may create some tension and compression. Due to the weight there will be uniform compression. If the width is sufficient, everywhere there will be compression, one side the compression will be more, another side compression will be less. If the width is small, one side there will be tension, another side there will be compression. So that is another concept. So two things I have told. The first one is the horizontal force should be less than mu times vertical force. The second one is due to the horizontal force and overturning moment and due to the vertical force there will be a distribution of pressure at the seabed. The distribution of pressure should be always compressive, a combination of these two, that condition also should be ensured. A composite breakwater is a combination of rubble mount base and vertical wall. It can, instead of vertical wall, it can be other form of superstructure. This is adopted where the depth of water is more than 15 meters. Then we have other types of floating breakwaters, other type of breakwater. So the three types of breakwater, rubble mound, CAISSON, composite, we can say 95% of the breakwater in the world they are of that type, whereas the other types maybe 5% it will be used. The advantage is a removable breakwater. This can be constructed by caissons or pontoons. This valves for trimming whilst afloat and for sinking when is in position, and pump connections for refloating more to the seabed. That is you can float it to a place, use the valves, and you can sink in position, and you can refloat also. They are inexpensive, easily moved from side to side. This can be often very quickly fabricated. This can be used for defense purpose also, but we do not use this because this is ineffective for long waves, and this also should be anchored. So this is typically a breakwater, floating breakwater with mooring. This can be used when the current is very high, it is environmental friendly. The cost does not depend on the water depth, whereas other type of breakwater the cost is proportional to the cube of the water depth. So it is insensitive to the water depth, in the sense the mooring line cost only has to be added. Mooring line cost is not more than 10% of the total cost. These are the three different types of floating breakwaters, but one problem with this floating breakwater is this cannot be used for long period waves. In one of the class I told you what is the period of the wave, range of period for the waves, what is it? 5 to 20 seconds. Sometimes it can be smaller also, 3 seconds also is there, but floating breakwater is used between 3 seconds and 7 seconds, never used more than 7 seconds, very difficult, but 5 seconds it is good. These are other forms of floating breakwater. It is called as a twin pontoon, the open compartment, then it is a A-frame. This is tire breakwaters, flexible membranes. This is a tire mat, the long mat. These are some of the photographs showing the various breakwaters built at various locations. This is called as a rubble-mounted breakwater. This is called as a tripod, which is used, and here we use what is known as a X block. So we will see the design in another class, but I was telling you about model studies. This is carried out in our wave basin. What you are seeing here is the tetrapods. The waves are coming and hitting the structure. As you see, when the waves are running over it, it loses its energy, nothing comes back. This here the armor units are stones which are used. Here you can see different colors. The bottom one is toe mount, this is under layer, this is armor layers. When the waves are coming, it comes and runs up over the slope, that is called as run up. When the water is running up, it can go on top of it and then overflow, that is called as overtopping. Here what is happening is it is splashing only. See, the run up is going only up to this level, and the waves what is generated is a random wave. Random waves have different wave heights and wave periods. Here you have a wave probe which is used to measure the waves, and on the lee side also we measure the waves. So this is the wave probe, and this is a frame, this is a probe which is sensing the wave. What kind of damage that will be there? 5% damage I was telling. Damage is some of these armor units may roll down, may fall down. That is called as the damage. Once the damage has happened, after the storm has subsided, you can go and replace the armor units. No complete collapse. So what is the design issue here? Design issue for this type of breakwater is you have to find out the weight of the armor unit. For rubble mount breakwater, you have to find out the weight of the breakwater. There is a formula what is called as Hudson's formula. I will be discussing only that formula, Hudson's formula. There is another formula called as Vandermeer. I will not be discussing that. I will be discussing only about the Hudson's formula. This breakwater weight, that is the armor weight, what you are calculating, that will be used to find out the weight of the underlayer, core layer and other things. So only one single parameter you have to calculate. So we will see that in the next class.